So thank you everyone for coming. I'll be brief, just a couple minute intro. I'm going to skip all the introductory slides about community. You can see it in the YouTube posts of the previous meetups. We just finished the meetup like 10 days ago. So there is not much new that happened except announcement that we firmed up one more meetup for October. And so this is the one with Joe Emison. He's a AWS Serverless Hero. Startup owner. Just last week, he's a startup in insurance tech, became a unicorn. So he's going to come back again and share how he did it. So that's awesome. I'm really happy about that. And then we're skipping July meetup for vacations. In August, we're going to meet to talk about customer data platforms. That's a new buzzword. The company that opened that segment of the market is called Segment, and they've already acquired by Twilio. So we're lucky to have them. And then in September, it's kind of back to school thing. And looking back in my 35-year-old career, long career, like the only language that didn't die is SQL. So we named it SQL Never Dies. We are still firming up the presenter. Like it will happen, just not sure who's going to be talking about that. So that's from us. Our sponsor is Manning Publishing. And if you stay until the end, if you do this survey, you will be eligible to raffle for any of their products. And then I'm really honored that Dirk, you joined us today. Please introduce yourself and take it away.
All right, thanks a lot, Daniel. Let's first verify that my screen is visible. Is that the case?
At the moment, your head. Oh no, here it comes.
Yep.
Now it works, right?
Yeah, it looks good.
Okay, awesome. So thanks a lot, Daniel and John, both for having me. It's really an honor. So let me quickly introduce myself. I'm Dirk from the AWS Solutions Architecture team here in Germany. So good evening from my end, and enjoy your lunch, whoever has lunch. And as we have learned already a few minutes before, some of you are past midnight already. So thanks a lot, especially for those folks for joining. So what do I do in AWS? As a solutions architect, I help customers on their journey to the cloud, on digital transformation. I also try to work on strategic topics with my customers, and I try to be the trusted advisor of them with everything around technology and software architecture. So from a industry vertical, I usually deal with power and utilities customers. And from a technology standpoint, I'm a big fan of serverless technologies, and particularly also everything around integration. I've been writing and talking a lot about integration patterns mostly, and reference architectures in that context during the past years. And yeah, it was very nice that Daniel and I met in Las Vegas at reInvent 2019. As he just said, I believe he attended all of my sessions. Thanks a lot again for that. And he recently approached me if I would want to contribute something to Serverless Toronto. And yeah, of course, I said yes instantly. So what are we going to talk about tonight? Actually, this is triggered by the way Daniel approached me because he asked, can you give a presentation that goes into the direction of that LinkedIn article that you published last autumn? And the name of that, or the title of that article, was exactly also the title of this presentation. So friends don't let friends rely on synchronous integration. And I thought, yeah, maybe I should exploit that article for the presentation tonight instead of repeating my reInvent talk, because that is available on YouTube anyway. So you are going to be some guinea pigs for me tonight, because then the slides are brand new. I'm trying out to really bring along and convey the content of that article. Friends don't let friends rely on synchronous integration. But I still have, for illustration purposes, brought a few of those use cases that I usually use to illustrate the broader integration patterns talk, so that we can also have a bit more flesh on the bone towards the end of the presentation. So that's quite a big introduction already. I don't know, Daniel, if you notice in between that I take too much time, then just tell me. If I should speed up here or there, then I can do that too. Okay, let's get going. So for rough orientation, the agenda, I will provide an introduction first so that we all understand what this is all about tonight. And then I'm going to point out what are the differences between synchronous and asynchronous communication. And then we are going to go through the different ways how we can actually produce asynchronous communication. So APIs, messaging with streaming. I hope the time permits for some use cases. And then I also have a few resources and a call to action. Of course, I cannot let you go without resources to learn more and a call to action. All right, now let's spend some time to set the context of everything and then dive into the details. And I mean, basically it's all about this, right? Companies deal with integration problems, and it is in many areas and on all the layers that you can imagine. And there are also dozens of ways how to establish integration between systems. And of course, like with every architecture decision, they have all their individual trade-offs. And the bad news really is, I mean, that's independent of this talk, that's the general bad news. Every software architecture decision sucks in the end, right? But you have to find, for your use case, you have to find the decision that sucks less than all the other options. But independent of that, so we can distinguish integration problems that touch systems within your own context, environments maybe, or sovereignty. And then there are also integration problems that touch your own context and third-party systems. And these third-party systems typically belong to your business partners. And a special case for this that becomes also more and more relevant are software as a service or SaaS systems. And integration scenarios with third-party systems come with their special reality. And these are not in the scope of today's discussion. Well, I should rather say concrete technology approaches and architecture for these cases are not in scope because many of the patterns that are independent of whether you integrate your own systems or systems cross-context. However, I can now and here and today shamelessly advertise that I'm working on a new talk that addresses integration and conversation patterns for SaaS and micro SaaS scenarios. And that talk should go into the conferences from September this year. I have also submitted it for reInvent. John and Daniel just asked me about it. But if it doesn't make it on the agenda there, I'd be, of course, honored to deliver it here at Serverless Toronto in any case. Daniel, what do you think? Does it sound good? I hope so. Okay. All right. So again, the scope of the examples I'm going to share today is integration scenarios with within your own context and sovereignty. And now there is one fairly prominent example for how we can easily provoke an integration challenge, which is the divestiture of a monolith into independent services. And this creates a new integration scenario as these services will most likely need to interact with each other. And why is this such a prominent example? Well, because lots of companies actually run monolithic applications, and those have grown over time. These monolithic applications often show a lack of encapsulation of their components. And this can manifest as spaghetti code and leads to an increase in coupling between components and a decrease in cohesion within each component. So, and then the consequence is a negative impact on several quality criteria. It can be one of multiple drivers then for companies to decide on a change in the architectural style. And the answer is often microservices or sometimes also self-contained systems. In case you haven't heard about self-contained systems, so SCS, you can follow the link behind the QR code on the lower right corner if you want to learn more. And the concept of self-contained systems is really interesting, and it addresses many reasonable aspects that you would want to have in your projects from both an architectural and an organizational standpoint. We could also talk about that for hours, but let's come back to the transition of our monolith. Or maybe one last word regarding self-contained systems. The advantage of that is, in comparison to microservices, the scope is a little bit broader, and it is well defined what a self-contained system is, and that doesn't really apply to microservices, right? Okay, let's come back to the transition of our monolith. In such a transition, components from the monolith would turn into independent services. And that's also a really great opportunity to work on the encapsulation and maybe fix the existing decomposition. Again, we want to actually work on cohesion and on coupling between components, and then particularly also in the resulting services of the divestiture. So as a result, these new services, they should be able, and that's our goal, to evolve and be operated independently from each other. And maybe the new look of our application is a bit like this now. But even if companies did that, often they still do not reach actually the goal to remove all the problems that they had with their monolithic application. And in addition, the application now is a distributed system, which brings also new challenges. And despite of a hopefully now clean separation of concerns and high cohesion within every system or service, there can still be a lot of coupling between services, and that can potentially cause problems. And speaking of coupling, let me quickly make an excursus and read the Hitchhiker's Guide to Software Architecture. Well, it's actually my guidance, but I think it's so universal that it's, in the end, everybody's guidance. But I really think that there are two design principles that are key for creating successful architectures. So in my experience, you should always apply divide and conquer to transform big problems into small ones. And hey, we just did it when we nuked up our monolith, so that's great. But then loose coupling is key. And it's key in order to reach nice benefits like independence, autonomy, resilience, polyglottism also. That's a big benefit also of microservices, and scalability. And maybe a few more itties for each of your smaller problems. Further down the session, we will inspect a bit why loose coupling is a good thing to have and how we can reach it. So my view is, if you rely on these principles and their implications, you will very likely be on the right track. But let's finish this excursus now and go back to our pebbles. Or maybe let's have a look at how the outcome of smashing a monolith can eventually look like for big companies, such as Amazon or Netflix. So the previous picture with our pebbles was very nice, but it didn't show any form of integration between our services. Here, we can see that apparently many services interact with many other services. And since there are apparently a whole lot of services involved on both sides, it's hard to see something through the fog. Therefore, let's have a look at a more schematic representation of the interactions between services for the Netflix case here. And so on the left-hand side is an excerpt. It shows what I want to point out here. It is expected, actually, that for many requests that reach our backend from outside, the processing of these requests requires further downstream requests to other services. And this leads to paths of various complexities through the services. What I mean by that is that for different kinds of requests that hit our backend, we can probably see the following cases. A request can be processed by one service, so no interaction with other services is required. That's a very good case. Request can be processed by a sequence of 2 or more services, but it can also be the case that a request can be processed by a tree of services, and then any other complex composition of these cases. And if we look on the left-hand side, the simplified architecture, the excerpt from the Netflix fork or planet, whatever you want to call it, you can see it, right? Requests are coming from the outside. They will run through a path through all the other systems. And this is where synchronous communication can become challenging, which we are going to see. So let's now continue with looking how we can integrate those services. And I'm not even going to talk about inhumane approaches like integration via database. Integration via database comes with extraordinary lot coupling, and I like to call that rather lousy coupling. There are, of course, I need to say that, valid cases in the CDC context also, where also a kind of integration via database makes sense. But instead, let's focus on what many folks would consider in their practice, integration via explicit communication over the network. And this brings us to the next chapter, where we want to discuss synchronous versus asynchronous communication. So let's begin with a generic view. How do parties communicate with each other? Well, we naturally have a sender and a receiver, right? And the simplest pattern here is the one-way communication pattern on the left-hand side. The sender sends out a communication item, and the receiver tries to catch it. In order to be able to transmit the communication item, a suitable medium is required. And for the one-way case, the sender doesn't expect a response. However, it might expect an acknowledgement, so that the communication item was successfully transmitted. And if it's not even interested in that, we call it the fire and forget communication. We can also look at the intent of the communication item. Typical intents are communication items that transfer a command, a document, or an event. And with a command item, the sender wants another party to do something. And the document item is used to transfer data, usually. And an event item is used to let other parties know that something has happened. Particularly for command items, so it's quite natural that the sender also wants to get an idea about the outcome from executing that command. And this is where the request-response pattern comes into play. And to be more precise, we are still looking at the synchronous request-response pattern here. And we can now call the involved parties also requester and responder, because we are doing a request-response thing. The requester, no big surprise, sends out a command item, and the responder works on it and eventually returns the result. Both the request and the response share the same medium once, and we will also become more concrete what that medium concerns. But they share the same medium. And once the requester has sent out the command item, it waits until the response comes in, which is the nature of doing it synchronously. And why am I stressing the synchronous part here? Well, our context is an X monolith. And we now integrate all those services that came out of our architecture refactoring. Due to the similarity to synchronous function calls that were most likely used in the old monolith between components, it seems to be a natural approach to architects to build synchronous communication over the network, also between those newly created services. It's really quite straightforward and natural, so that's most of the time the outcome. And that communication over the network is also most likely done via HTTP. So we can make our medium more concrete now and say it's a HTTP connection. If we further assume that our architects have designed a nice REST API, and we should actually be on a good path to reach our second major design principle, which is loose coupling. Well, yes and no. So a manifestation of the REST architectural style based on HTTP should lead to a loosely coupled integration. That's all the idea behind it. After all, it is in the end based on the web architecture. The web is an undoubtedly very large distributed system with loosely coupled nodes. The first pitfall is here, though, that most of those alleged REST APIs out there are actually not RESTful, which is really a pity, but it is. That's the case, because they violate one fundamental principle, which is the use of hypermedia, or in other words, links and link relations. Even though people try to put lipstick on the pig here by using fancy REST maturity models, where using hypermedia is only an optional top stage, it is in fact a strict requirement. And in this rant here, if you want to follow the link, you can take a picture now. Roy Fielding makes it clear, REST APIs must be hypertext driven. Without hypermedia, you simply add a ridiculous amount of coupling between every client and every specific implementation also of your REST API. Another pitfall in that respect is when folks use tools to generate client and server code. And that code then marshals and unmarshals request bodies based on schemas. That usually couples both sides to a fixed evolution stage of your resource representations and leaves you totally inflexible. So if you want to change something, you need to redeploy all sides. And let me also add a very unpopular opinion. API versioning is totally overrated and can add coupling too. But let's stop ranting and go back to the actual topic. So even if we have a super nicely designed hypermedia API, and with that, a conceptually loosely coupled integration from an API perspective, we will still experience coupling at runtime. But what happens at runtime? Well, synchronous request response blocks resources on both sides for the time it takes to send out the request, do the processing, and respond with the result. And when a request reaches the application from the outside, processing often involves multiple servers along a path that this request spawns through the service of the application. Well, this is what we just saw before when we looked at the microservices planets in Amazon and Netflix. And let's maybe project this here once more. So synchronous communication blocks resources in all involved services. Worst case, for the time the entire processing takes. Additionally, problems in downstream services can accumulate upstream. And this is why there are mitigation patterns like circuit breaker in the first place. So particularly under load, a synchronous integration approach can jeopardize the reliability of the entire system. And it can also require excessive horizontal scaling with a respective cost attached. Another aspect that you might not want to have. Asynchronous communication, on the other hand, reduces temporary coupling of resources along a request path to a minimum. And how is that? So this is now described on the right-hand side here. Looking at the interaction of a pair of services, it only requires one service to send out a request to another service with a quick acknowledgement. And that acknowledgement just tells the requester that the request has arrived on the responder side. And all the processing can now happen separately without further runtime coupling between the parties and until another interaction needs to take place to send the response back to the requester. But then that's from the perspective of the responder, another request to the requester. This implies also that there are now two distinct media in use for the transmission. So one for the request, one for the response. And in our case, we see now two HTTP connections. The one that transmits the request, which is document A, and the one that transmits the response, which is document B. However, now, in practice again, due to the similarity with synchronous function calls, development teams may perceive synchronous communication between services as simpler to implement, and they are more familiar. And while asynchronous communication requires some additional considerations, and of course, that's the case. For instance, how a response finds its way back, or how a requester can match an incoming response to a previous request. There are, however, standard patterns and publicly available resources that address and explain how to solve this. So there's absolutely no reason to fear asynchronous communication. It's a little bit more to do, but it pays off, particularly under load. So there are basically two patterns that we need to employ here, which is correlation ID and return address. Correlation ID, that's a piece of meta information that the requester needs to add to the request, and it is a unique identifier for this request. The responder is then tasked to keep that correlation ID and inject it also in the response that goes back to the requester. And then the requester can match an incoming response to a previous request with the help of the correlation ID. On the other hand, the responder also needs to know where it should actually send its response, of course. So what's the URL for sending out the response in this case? So the return address pattern instructs the requester to add, again, a piece of meta information to the request, and that tells the responder about the URL for the response. So it's in the end not that hard to implement, right? And there are even orchestration tools that support all this handling. One really nice example for that is AWS Step Functions, which is a cloud-native and serverless service, and it makes orchestration simple with the concept of workflows. So purely due to the independence of request and response mediums and the reduction of coupling, we should think asynchronously in order to make sure we reach a certain non-functional requirement. And that brings us to the common sense statement that we see here. And it's not exactly the one that some of you might have expected because it's more general. So, and that's my common sense generalization of a quote by Tim Bray. If your application is cloud native, large scale, or distributed, and doesn't include asynchronous communication, that's probably a bug. And we will encounter the quote in its original form also in a bit, of course. And that also means we are not yet done, right? So we can still decouple further. We have decoupled quite a bit by using asynchronous communications between our services. But now let's continue with our current status. How much coupling do we still have left in our architecture? Because it's very unfortunate, but even after turning an API-based integration from synchronous to asynchronous communication, there is still coupling involved that can lead to problems. Messaging systems, on the other hand, address this and can further reduce coupling. So on the left-hand side, again, we see the async request response pattern illustrated for APIs. One aspect is the location dependency here. Every request sender needs to know the locations of its request receivers. Integration via API couples request senders to concrete instances of its request receivers. And sometimes a request sender also wants to fan out. And the same request should reach multiple request receivers. But then this requires the sender to know all the locations of all receivers. And adding more receivers, removing receivers, changing receivers will lead to code or configuration change in the sender. Another aspect is the availability dependency. Every request sender needs to rely on its request receivers to be up and running, right? Naturally, a request sender can only send out a request if the receivers are available. But request receivers can also run into problems, of course. Everything fails all the time, a nice quote from Werner Vogels. So they can be overwhelmed by spiky request patterns. They can be unavailable due to planned or unplanned maintenance. And in all these cases, the request sender needs to manage retry and mitigation techniques. That doesn't really sound like something we want to handle on our own, right? So messaging systems actually address all these aspects. They use channels to decouple communication partners. Senders produce messages into these channels, not into the other sides, into the receivers. Receivers consume messages from those channels. So both sides don't have to know anything about each other anymore, which sounds great. Only the message channels are known to the communication partners. And messaging systems usually offer two types of channels. First one is point-to-point, which is implemented by queues, where every message is consumed by one of potentially many receivers, and publish, subscribe, or fan out, which is implemented by topics, where every message is consumed by all of the potentially many receivers. And we will dive into this in a second, but let's also quickly talk about the location aspect. So looking at the location aspect, if we use messaging channels, a request sender can now act on top of business logic. That means the semantics of a channel and not anymore the technical details about their communication partners. The locations of those are not relevant for the request sender anymore. And when I say focus on top of the business logic, I relate to the fact that oftentimes those message channels are also programmatic. That means they are used for a certain use case. Each request receiver also can autonomously decide to consume messages from a channel. That also solves the fan-out scenario without any change in a request sender. And since queues can buffer messages, they also address the availability dependency. In case there is no receiver available, or the available receivers cannot process the messages at the same pace as they are produced, a queue can retain messages and flatten peak loads until receivers are able to catch up. Okay, so I guess that's quite a bit at once. So let's dive a bit more into the specifics of messaging. And before we talked about communication exchange patterns, and let's now continue with making this specific to messaging. All right, so again, we have one way versus asynchronous request response, but now it's specific to messaging. We can see again in the one-way scenario, there's that messaging channel or message channel that decouples sender and receiver from each other. Sender sends message A into the channel, receiver receives it from there. And the same for the asynchronous request response case. We have a message channel for the request, that's message A, and for the response, that's message B. And we already have learned about the return address and the correlation ID patterns, also about message intents. What I want to point out here is on the left-hand side, the pure integration between sender and receiver through a message channel is what we call an integration pattern. On the right-hand side, that is a bit more than purely integrating the requester and the responder, because we have a conversation now between the requester and the responder. We have a composite pattern that makes use of that integration pattern of a message channel. And we use it once for the request message and once for the response message. So then we spawn a conversation between requester and responder. And that's why we call this a conversation pattern. Okay, now let's have a look at the concrete different types of message channels that I have already mentioned. So again, a deeper look on point-to-point channels or queues. So as I said before, each message is consumed by one receiver. And that makes it really simple to scale also on the receiver side. So if you notice that your receivers are overwhelmed by the pure load of messages that are available in the queue, you can just add more receivers, and they can add also consuming all those messages from the queue. One note, maybe just for simplification, I have added only one sender on the left-hand side. It can be multiple ones, but it makes the diagram a little bit easier to digest. Okay, so very simple to scale out. And that characteristic actually also can make us call a queue a load balancer. And there's another very nice capacity of a queue, which is that it can buffer messages for you. And with that functionality, it can flatten peak loads for you. So all in all, you could also call a queue a buffering load balancer. So very useful. Looking at the other kind of message channel, publish, subscribe, implemented by topics, the characteristics is a little bit different. So here, each message is consumed by each of those subscribers. Conceptually, topics have no buffering, but the many in-market products that you find out there have sometimes quite sophisticated retry mechanisms, but formally there is no buffering attached usually. That also means if your subscribers are offline, they will miss messages. And you can imagine it like if you turn on your radio, FM radio, if anyone knows what FM radio is or used to be, then you can listen to the radio show. And if you switch it off, you will miss the next radio show. And if you look at the question, how can we scale out on the subscriber side? Now, that is a tough one, because if you find that your subscribers are overwhelmed by the loads of the topics and you add more subscribers, due to the characteristics that every message is consumed by every subscriber, you will not make it better, you will make it worse. And there's, of course, also a way out of this, which is actually a composite pattern again, which is the topic queue chaining pattern. So here we send messages again into a topic, but we don't directly attach our consumers to the topic, but we put a queue in between. And that brings us, in the end, the best of both worlds. We can fan out, and we have at the same time also the consumer scale-out capability, and we have the buffering load balancing capability all at the same time. So that's pretty cool. And as you can see in the service in the middle, it already has spawned 3 consumers to handle all the load. And with all the additional decoupling capabilities that we have seen here, we can now come to the real quotation of Tim Bray, which says, if your application is cloud native, large scale, or distributed and doesn't include a messaging component, that's probably a bug. Now, I would also quickly want to add and share with you what are actually the AWS services. Since I'm from AWS, I need to mention the AWS services that also implements that functionality. So first, from the cloud native and serverless part, we have Amazon SQS that implements message queues, and Amazon SNS, simple notification service for the publish subscribe scenario. And sometimes folks also are constrained to industry standard protocols like JMS or MQP. That also comes quite a bit in lift and shift and migration scenarios. Then there's Amazon MQ, which delivers a managed RabbitMQ or Apache ActiveMQ experience. And for the sake of completeness, I would also like to mention that there is the AWS IoT Core message broker, which provides support for MQTT over WebSockets, and HTTPS for publish only. It comes, of course, from the IoT context, but you can also perfectly use it for push notifications to mobile clients. All right, so we could actually now add yet another version of the Tim Bray quote talking about streaming. Because next to messaging, well, there's also streaming as yet another approach for asynchronous and loosely coupled integration in a fan-out manner. So you would compare it to messaging topics. And in the community, there's often confusion about what approach is the right one for a given use case or scenario. And I really have a lot of sympathies with all those software architects out there, because it becomes more and more difficult every year, because the concrete products for messaging and for streaming, their feature set grows and grows, and it becomes more and more fuzzy and difficult to distinguish. But as a rule of thumb, for a use case where every single message has a meaning or a function, messaging is usually a good choice. And for a use case where a large amount of messages, often referred to as events in this case also, where a large amount of messages has a meaning or a function, then streaming is usually a good choice. And typical use cases for streaming are aggregations, identifying trends, or finding anomalies. And let's have a look at an example to make it more tangible. What is the difference between message processing and stream processing? So let's use this example picture. That's my colleague Christian and I. We are above Mos Eisley spaceport on Tatooine. And now, if we consider message processing and we say this picture, that's the content of our message. Let's say it's a document message. So the entire picture has a value for our application, right? The picture and each individual message is a unit of work. If we also quickly look at the way how messages are consumed in messaging, that is the case that every message is actually deleted after consumption. We need to memorize this. If we look at stream processing, on the other hand, So here, as I said, batches of messages, a lot of messages altogether are the units of work. If you imagine that we cut down this picture into, let's say, 1,000 tiles, we would process all those tiles at once and then get the big picture of the actual payload from processing all those tiles, right? A single tile doesn't bring a lot of value and a lot of insight, but if we process the entire batch of messages, then we get an insight. And another difference here is also how are messages consumed from a stream. The thing is that they are actually retained in the stream after consumption until they eventually expire. And this also means that a client needs to be aware, they need to maintain a cursor on the stream to be aware what did they already process and what is yet to be processed. So that's in general message processing versus stream processing. But as I said before, it's quite tough to distinguish, particularly because the functionality grows and grows and it comes closer and closer. And if we spoke about messaging and streaming already, then maybe a few of you would ask the question, hey, Dirk, what about buses? Of course. Well, why have buses not been covered yet? Well, from a pattern perspective, they are quite similar to messaging topics. However, the scope is an application, in an application is usually more universal. While you would typically use a messaging topic for every specific use case, you typically use one bus for your entire application. And the functionality with messaging topics is usually quite basic. Well, they can accept and deliver messages really well at high speed and scale, but there's not a lot of functionality on top. An event bus, on the other hand, typically comes with a lot more functionality, such as content-based routing, but also it comes with a few constraints, such that message bodies have to come in a certain format. And additionally, that plus in functionality also needs to be paid with a little less throughput. And as with all tooling, your specific use case determines your decision for a bus or topics, and you can perfectly use both in your application in parallel too. And of course, there's also a cloud native and serverless service in AWS that implements the bus functionality, which is Amazon Event Bridge. And again, both messaging topics and an event bus are fan-out patterns as well as streams are, of course. So for the sake of completeness, let me also quickly share the AWS services that implement those fan-out patterns. So if we look at cloud native and serverless services for streaming, we have the Amazon Kinesis family with data streams, data firehose, and data analytics. For those who are constrained or like to use Apache Kafka, we have Amazon managed streaming for Apache Kafka. And as I have mentioned already, for an event bus, we have Amazon Event Bridge. Now, I believe we have a bit more time, so we can take a look into a few use cases. And Daniel, you let me know in case it becomes too late. But for the time being, I will start with one use case to illustrate all this a little bit more. And the context of those use cases is Wild Rides, which is our preferred fictional technology startup. And what they do, their business is they disrupt individual passenger transportation by replacing old taxi cabs with unicorns, because it's much more fun to ride on a unicorn than in a taxi cab, and it's of course much more magical. And I have that one use case I want to start with, which is called Submit a Ride Completion, which illustrates actually quite well how messaging can have a significant advantage over APIs and of course over database integration. So the scenario is as follows. A unicorn has just dropped off a passenger at their final destination. And now the unicorn wants to notify the Wild Rides backend about it, so that eventually also Wild Rides can collect the fare from the customer. So it uses the Wild Rides unicorn app, pushes the button, and then it will most likely turn out that a REST API request is sent somewhere to the backend, which is the right management service. It runs in the cloud on AWS. It hits the managed API gateway, and then there's a piece of code which is called the completed writes processor that most of the time would start persisting that information in the database. It can then logically create a new resource and return to the client to one created. All good. We have recorded everything and you're good to go. Now, we can park the client side a little bit, and we can probably easily imagine that there are a lot of other services within the wild write context that are also interested in knowing about that a unicorn has just delivered a passenger. For instance, a customer notification service, customer accounting service, a loyalty service, a data lake ingestion service. Everybody has a data lake, so we have to have an ingestion service. And the extraordinary write service, it's a special one. And this one is only interested in writes with fare and distance above a certain threshold. And as we can see already, the write management service, it has a database, right? So we can ask the question, should we simply integrate via database? All the other services could connect to the database, and then they know everything already. I don't know, I cannot see you raising your hands if you like this idea, but no, we don't want to do it. So integration via database, I mentioned it before, but it adds so much coupling really to this architecture. And this is, again, something that I like to call lousy coupling. And but if somebody in your team approaches you as a software architect with that, still, of course, you need to be friendly. And that's why the red traffic light here has the shape of a heart. I mean, I also mentioned before, there are some reasonable use cases for integration via database, for instance, for legacy workloads, where you cannot set up integration via messaging because you cannot add anything to the code. The developers who have built it are long retired and so on. And here it's super helpful to stream CDC events from the legacy database to interested parties. And yes, that's actually a streaming use case more. And also changes in the database schema are not expected here. Another reasonable use case, of course, is to stream CDC events from any database into the raw data tier of your data lake. So next try, integration via REST APIs. Yes, absolutely, but it comes with a but. So what you have to do then here is that the completed writes processor would have to send HTTPS requests to all those interested parties. So it has to know about them. And that would employ another pattern that is called a recipient list. So it has to be within the completed writes processor, or it has to be a separate component, the request distribution service, which would then employ the recipient list service pattern. And in addition, you would also have to manually implement the filter for the extraordinary write service. So that means, in consequence, there's new code you have to maintain and operate on your own. It potentially adds a bit more coupling between the completed writes processor and all the other services. And that's all things that we don't want to have, right? And why don't we try with messaging? Integration via messaging? Yes, absolutely. So in this case, we add an SNS topic here, the write completion topic. And all services on the right-hand side can autonomously subscribe to that topic, and they will receive all the messages from that topic. Also, Amazon SNS supports the message filter functionality, so you don't have to implement this manually. The extraordinary write service can configure it autonomously and tell the topic about it. And if you want to add more resiliency and load balancing functionality, you can employ the topic queue chaining pattern, add the queue in between. So now you can also securely spin down every service for planned or unplanned maintenance, and you will not lose any of those messages. Now, I have spoken about streaming stuff into your data lake a few minutes ago. And actually, a better solution here for the data lake ingestion service would be to not have a data lake ingestion service at all, but rather directly attach a stream to the write completion topic and have that offload all your data in the raw data tier of your data lake, which is part of your modern data platform. And another consideration that we can do here is maybe we want to replace SNS with Amazon Event Bridge, right? That would allow us also for content-based routing on those messages, because the one thing you need to take into account when you want to use the Amazon SNS message filter, it can filter only on the header of your message. That means you would have to add those values for fare and distance additionally into the header. You don't have to do that when you use that content-based routing functionality in Amazon Event Bridge. So that was one illustration for the use case. And please let me know if we have time for another one or if we should rather come to an end.
You can keep going. We still have time.
Okay, awesome. Then I wanted to share one other example, which also illustrates a bit how you can decouple within one service. So not only between one service, but within one service, which can also become a non-functional requirement depending on the scale which you're operating on. So this use case is about free booking campaigns. And what the Wildbright's marketing department does is they currently run massive campaigns with the call to action, book your ride for next week already this week. And if we look at that, I believe we can do all the processing at once. So in this case, a Wildbright's customer uses their app, press a button again, they have added or entered all the data for the ride for next week. So from where to where and when should it happen, and it goes into the ride booking service. There we have a pre-booking processing resource. Again, quite trivial. It stores everything in a database and can respond to the client 201 created. We have accepted your reservation and you're good to go next week. Now, the campaign becomes a little bit more aggressive. Now it says book your ride for next week already today. So not sometime during this week, but today already. That means we have to count with a little bit more traffic that can hit us. Okay, so again, the customer uses the app. The app sends out an API request to the ride booking service. It goes through the managed API gateway. And watch here. Now we have a pre-booking pre-processing resource, not a processing resource anymore, but a pre-processing resource. And what it does is it forwards, after it does a sanity check, obviously, but then it forwards the pre-booking details into the pre-booking forwarding topic and does not do the actual processing. And when it is done with that, it can return and respond to the client already. And what's the reason for this here? It is that we want to take care that we can always answer the client request in a timely manner. And what we want to avoid by all means is a timeout. Therefore, we just accept everything and return to the client already to accept it. So, dear customer, we have received your data. We are now processing it, but we are not yet done with it, but we are processing it within the next minute or so. And that's good enough for a customer. It's only important that the actual data has been transferred successfully. Now, what happens behind the pre-booking forwarding topic? So we are again still in the scope of the ride booking service. And here, for the sake of resilience and also ability for load balancing, we are attaching a queue and then the actual pre-booking processing resource. And also, just to add another consumer for this topic, we have again the data lake ingestion service, and we will probably also replace it with a stream in a bit. just for the sake of completeness, also here on the lower right-hand side, there was no space left for the database icon, but of course, it will still be persisted. Now, the next stage, escalation stage, if you will, of the campaign is that the call to action says book now. So all of a sudden you receive a push notification, or you're watching a show on TV. Is there anybody watching TV still? I don't know. I'm doing it. So let's say right before the 8 p.m. news, there's a commercial on TV. Dear Wild Rides customers, book your ride for next week now. So that means we can expect really a lot of requests all of a sudden. One very simple thing that we can do is just put a queue in front of our pre-processing resource, an SQS queue that is, and also make the SQS API available to our client, which is something you could do if you are the owner of that mobile app. But if you want to make sure that you expose your own nicely designed REST API, and you want to open your API to third parties or even long-tail developers, you would not want to do that. So you would still put the managed API gateway in front of it, and then you can keep your nicely designed API. So in this way, you can also make sure that all those requests that are coming in are processed, because the SQS queue, the pre-booking submission queue, takes care of that. And again, I wanted to point out, of course, I would rather replace the queue that was attached here for the data lake ingestion service by a data lake ingestion stream that directly loads everything off into the raw data tier of your modern data platform. And with that, I believe another use case will not fit, but I have a few resources for you to share. So first of all, there's a blog series. So you can read again about the use cases and patterns from this talk, and actually a lot more. So tonight I've replaced several patterns by giving the long introduction about synchronous versus asynchronous messaging, and APIs synchronous versus asynchronous communication, and APIs versus messaging. And in this blog series, you can also read about a lot more integration patterns that also involve messaging. Then there's also a hands-on workshop where you can gain hands-on experience with building the use cases from this talk, and a few more too. And of course, you can reach out to your friendly AWS solutions architect, provided that you are an AWS customer, of course. And one thing to keep in mind, please, loose coupling is always better than lousy coupling. And with that, I'm almost done. So in this talk, in a quick summary, I pointed out the advantages of asynchronous integration approaches in a microservices scenario. And as always, again, disclaimer, for any use case and integration scenario, it's important to inspect the requirements that you have personally in this integration scenario, and then carefully determine the integration approach and the best tools. And that can be APIs, that can be messaging, that can be streaming, or what have you. And there's never a silver bullet for everything in software architecture. If somebody tells you the opposite, like if somebody says it has to be all Kafka or so, then use caution. And yeah, with that, please feel free, connect, reach out to me. You see my connection details on the lower right corner here. I'm always happy to discuss integration challenges, provided I have bandwidth, of course, so that's not always the case. And other than that, thanks a lot for listening, and have a great weekend. I guess we are still here for some Q&A and discussion, right?
Yes. Thank you so much, Dirk. This is amazing. Now folks can see why I attend every workshop and session you have. So such a clarity, precision, through German engineering. Thank you.
Ooh, thank you.
So
Don't
you can open your mics. No, I'm not. So we have a bunch of questions in the chat. You can start from there. I think after LinkedIn profiles, there are some questions. and then you can turn on the mics and ask Dirk. It's going to be
Okay. Let me
fun
find the chat.
So
okay. Okay.
So
What time
Fahim,
is the first question?
I think Fahim, I don't see. Okay, there is one. Magnus.
That's Magnus
In what
from
situation
63,
would
right?
you 7 bridges better choice than SQS and SNS?
Yeah, right. So that is basically the case when you want to have that added functionality that Event Bridge has. So the advanced filtering, what I have mentioned, I called it the content-based routing. It's not the term that is used in the Event Bridge documentation, but it's basically that. And I use content-based routing because it's one of the well-defined integration patterns also in Gregor Hope's book. Just comes to my mind, I forgot to add the link to Gregor Hope's website here. If somebody, Daniel or John, can add it to the chat, that would be great. Yeah, so if you want to have the advanced functionality of Event Bridge, also with the schema detection and so on, you would go for that. And sometimes it also architects feel it is simpler to manage because you have one event bus in your infrastructure and not maybe 50 SNS topics or so. Some perceive this as easier to manage. For most of the use cases, the throughput of Event Bridge should be good enough. But then there are, of course, use cases where you need the cloud scale, web scale, global scale, throughput capability of SNS. And you also mentioned better choice than SQS/SNS. So we need to compare Event Bridge with SNS because both are fan-out services and SQS is not. So we cannot compare SQS with SNS or Event Bridge, but we can combine both, of course. So you can also combine SQS with Event Bridge and use that to buffer messages, for instance. Yeah, let me know, Magnus, if that is enough of an explanation.
Yeah, sure.
Otherwise,
good explanation. Thank you.
Okay, awesome. Then what do we have? Gerardo, some systems have only databases connections for messaging, REST API or SOAP. Are these two questions? Yeah, shoot, Gerardo.
Basically a comment. Sometimes you work with the things you have. And so, although for years I've been fighting synchronous communication because of all the things you said and the reliability that comes with it, or the lack of it. Sometimes the systems I have to integrate with have only databases at the most. Anything that's connected with messaging is unreliable. And even then, sometimes I only have files to work with, and so the communication is done through is synchronously done using file transfer, which is something that puzzles my mind. But okay.
Yeah, I feel you, and yeah, sometimes there's not a lot you can do. I mean, there are even cases where it will always remain like this, like what I've mentioned. I'm not going to touch today. Integration with third-party systems that might require you sometimes to use file transfer if there is nothing else. But I mean, if you have database connections, you can at least try to abstract as much as you can from working with that database and set up something like a CDC stream. Maybe you have the ability to stream all the CDC data into your data lake. And from that moment on, you are at least independent from the concrete database. Of course, you are not independent from the format of the data, but you're independent from the concrete database and also from its availability. And that actually is a reason why we also advise our customers. If you want to set up a modern data platform, which naturally contains, on AWS at least, an Amazon S3-based data lake, you should have multiple tiers in your data lake. And the first one is the raw data tier. And try to set up a connection to all your source systems, which you want to collect data from. And once you have set up this integration, you can feed all new data into your data lake. And from that moment on, you don't have to rely on those other systems again, but you can always fetch the data from your raw data tier. This at least gives you independence from the availability of those other systems. But yeah, if you have only database connections, you have only database connections. But as I said, you can at least try to abstract from it as much as you can, for instance, with the CDC stream. And then you also mentioned REST API or SOAP. SOAP is, of course, also a big crime because it violates HTTP. And it also comes with so much coupling and all those, let's say, horrible WS Death Star services on top that people were saying you have to have because they're enterprisey, but actually you did not. But it was always a pain to fight against that. Yeah, so SOAP, there are leftovers of SOAP quite a bit on the planet, I believe. But if somebody today asks you to use SOAP, then you should run away. Okay, Fahim, if we are using, say, SQS to communicate between two APIs, what would that mean if, would that mean I would need two SQS queues, one queue request and one queue for response? Exactly, that is exactly what it means. And then 2 queues per every pair of API communicating. Well, it depends, I believe. Can you maybe elaborate a little bit what you mean with APIs in terms of scope here in your question?
Turn on your mic.
Is Fahim still here?
That's okay. You can move to next question. He'll go back.
Okay.
Oh, he's here. Just imagine.
Let's...
He's here. Just imagine a few services that are communicating with each other.
Okay, let's also let me quickly read the last sentence that he wrote. If not, and you have a single bus, how would the individual APIs know that the message was for them? Okay, no, I think I get you. Yes, so you create for an event bus, you create rules, and these rules determine where the messages are routed to. So sometimes we also call an event bus, we call it an event router, because you can, and that's probably also one of the at least differences in terms of a mental model for SNS topics or for messaging topics in general. You assume that every subscriber to a topic wants to see every message. And if there are exceptions where subscribers only want to see, I don't know, 75% of the messages, they would use a filter like the SNS message filter that we saw. And with an event bus, it's different. And that's why I also said usually you would have a concrete SNS topic for every tiny use case. So it's like a programmatic topic. And in terms of an event bus, you usually have one in your application. And that's why you have to have those filters that allow you determine, okay, when a message comes from this source and when it has this and that property in its payload, it should go to that consumer. I hope that explains it a little bit. Then we have Magnus once more. Do you think the SQS SNS should belong to the sending or receiving end? Ah, I love that question. Super. Or be entirely independent? I'm thinking in terms of ownership, version control, IAC, etc. So my take here is, if a microservice wants to let others know about that something happens using an SNS topic, it should be in the CloudFormation template or the SEM template or whatever IIC tool you use. It should be in the responsibility of that service. Now, if we apply topic queue chaining, then I personally consider the SQS queue already part of the receiver side. So that means, and also you would have one SQS queue per receiving service. That means I would locate those SQS queues in the IAC scripts for the receiving services. But the SNS topic is part of the sending services. And there are, of course, other views where people say, no, this all is, I don't know, shared infrastructure and needs to be centrally maintained or so. I think that adds, more delays and also more points of failure to your overall operations things you do. So I wouldn't do it. But of course, there are different views on it. I would put the SNS topic as part of the sending service and the SQS queue as part of the receiving service. Okay.
Great, thank you.
Then,
Makes sense.
Then Fahad, do you believe the integration through APIs is obsolete for microservice-based distributed architectures? Would you still adopt them in any particular scenario? Let's see, if I build something from scratch, I would not rely on APIs today. I would rely on things that use something like a broker instead. And I would, of course, rely on cloud native services like Amazon SQS, SNS, EventBridge, Kinesis, and what have you. There may be, you might be forced into using APIs when you don't have full control of all the services. Like if you say you have 10 services in your landscape, and every team in every service has full autonomy, and one service team decides they can only do REST APIs for whatever reason, then you might be bound to that. Or if you need to integrate with third-party providers, then it's most likely that you have to integrate through APIs, because third parties would probably not open their message broker or their cloud-based message service to you. But that's actually also a case I'm working on for the SaaS and micro-SaaS talk. So yeah, in sum, I would personally not build my own backend services in my own backend based on APIs. What I would maybe do is, for testing purposes or so, add additionally also an API resource to it. But for production use, I would rely on messaging. Okay. Kartik. Okay, no question here. Daniel Gorbatov says, regarding last question, Magnus asked, please address permissions policies that need to be explicitly defined in order to publish SNS or send messages to SQS. Yes, that's correct. So you would usually also, let's say, agree on a certain naming schema of SNS topics and SQS queues, particularly in the request response case. So if the responder of a request needs to send back the answer, the response to the original requester or so, I would also consider that queue as part of the original requester's scope. And it has to grant access rights to that SQS queue. So if you can work with IAM rules, for instance, that are based on certain naming, and then provide rights to write into those destinations if they fulfill a certain naming scheme. But that is a really good point that needs to be taken into account. Fahim, again, just imagine a few services that are communicating with each other, say 3 services. How many SQS queues would we need? Assuming service A needs to get responses from service B, and service C gets the info from service D. Does it mean 6 SQS queues? It could mean that, yes. And there's nothing wrong with it, right? And but that's also, on the other hand, what I mentioned a bit earlier. Sometimes people feel they don't want to have let's say that management, that perceived management overhead with managing a lot of SNS topics and SQS queues. But again, we would have to compare SNS topics here compared to EventBridge, where you only have that one infrastructure component, but then you have to maintain all those rules, of course. Yeah, there's no restriction in terms of how many queues and topics you can have, and just creating those queues and topics also doesn't cost you. Only the request to create them, but having them doesn't cost you anything. Okay, and that were all questions. If you have more, just push them out now. Otherwise, I believe Daniel takes over for the closing.
There will be more questions. You can turn on the mics, John. You are expert in this area as well. So.
Yeah, I don't have any other questions right now. I mean, I think that we covered a lot of the good material there. I was just thinking that if some people need to get back to work by 1:30 or so you might want to do the raffle in the next 5 minutes or so.
Okay, I'll do that.
If we have more questions, they can certainly keep coming. Yeah.
Perfect. And I posted the link to your talk before COVID when we were still offline, like normal.
Yeah, that's the stuff in there is going to be a little bit dated now, because when I did that talk, there was no such thing yet as EventBridge, and there was no such thing as a WebSocket in API Gateway. So I was actually using the MQTT functionality out of the IoT core stack in order to do the two-way. So it's kind of dated, but it's probably still a good listen for anyone who's interested in that, for sure.
That is cool. And you still have time to do survey and ask questions while I'm preparing the survey for any mining product.
Yeah, John, Daniel pointed me to your talk yesterday also. And I believe it is still actually valid to look into the IoT core message broker, particularly also for sending out notifications to mobile clients. So we have actually a hands-on workshop. It is called Innovator Island, I believe. And there we also use the AWS IoT core message broker to send out updates to mobile clients. And that's really simple to use also.
Yeah, it did lend itself nicely, because the nature of IoT is because you've got these devices all over the world, and it has to be resilient to disconnections that can occur. Like, let's say that you've got like sensors in a farmer's field or whatever they may be. So that works out really well with just the nature of a mobile phone or client. Like, you can get disconnected at any time, and that protocol has the ability to reconnect and catch up events. So that's why I found it did work really well for that case. Yeah.
Mm-hmm.
Any other?
You keep talking. I'll pull out the survey. So there is only, I think, 12 people who did the survey. So feel free to do it, or put your name here. It doesn't, if you don't want to answer all the questions. Feel free to keep talking. Okay, I'll share, so there is no odd silence. And Dirk, thank you for the offer. Like, regardless whether they accept your talk or not, you're welcome to talk again. Not everybody can attend it. It's always a treat to listen to you. I feel like in university, really. Like, it's a perfect lunch to learn. So
yeah, that would be great.
And we also, after reInvent, we always have kind of recaps. So we don't need to do full recap. They can always Google it. You can kind of do another version of your talk or whatever you didn't have time to do. That would be cool twist to post reInvent meetups. So Planas.
Somebody
December,
just
January.
mentioned that one of the links you shared doesn't work. I
Which
don't know
one?
which one.
Oh,
Wing refers
that
to.
was the typo. That was the typo. It's the bit.ly. I misspelled bit.ly. So use the link right now, like one bit.ly/SLSTO. So use the one that I posted it on 1/26. That one should work, I believe. People are still entering names, so I guess it's working. Let's see. Let me share the screen so you see what I'm up to. So we're using this wheel of names. These are the people from the last meetup. Anybody else wants to add his or
Yeah, if
her
anyone
name?
needs a name in there that didn't come through, just put it in the chat and we'll
Yeah,
get
I
it.
added Dirk.
I guess Wing Wong maybe didn't get it sorted out there. The link wasn't working.
Okay.
And Balai.
And then anybody else? We have Wong.
Garish.
Okay. And it's really any mining product. Anybody here going to reinvent beside Dirk?
Oh, Wing Wong wants his name in there as well.
You have William Wong or some?
No. Oh, is that the same person?
I don't know. No double dipping.
No, I don't think. I think it must be different. Let me just check.
Okay. I'll put the names.
The Wheel of Fortune is the best part.
And they do have good books, and you know the price is like, even if you don't win, it's affordable because you get both digital product and the print product. So can we go?
I think Wong is saying that he is William. So maybe we've got him twice.
Okay.
Yeah. Sorry for the confusion.
Okay. So let's do the spin. Ta-da! Ready? Good luck. Ta-da! Who's going to be? Fahad.
Fahad, congratulations.
You're with us? You have to be here. Fahad, if you left.
Oh, he's there.
Yes, perfect.
I'm here.
Perfect,
Absolutely.
perfect. So please share your email address with us here in the chat, and then I'll connect you with nice folks from Manningen. Thanks again, everybody, for attending an awesome lunch and learn. We should do more of those, and hopefully see you for real. Dirk, appreciate, like always, to learn from you, and thank you for your time. Anything else, John?
No, I think that's it. I mean, as far as your last question, Dirk, I'd love to go to reInvent. I'm not sure that I can afford the time or the money yet, but we'll see. Hopefully I'll get there.
Yeah, would be great.
Yeah.
Thank you. And then
Awesome.
we see you after reInvent.
Yes. Okay. Have a great weekend, everybody.
Everyone have a great weekend. Yeah, thanks.
Thank you.
Bye-bye.
Enjoy the summer. Ciao.
Bye bye.